Chapter 6, Section 3, Part 1, Similar Figures. Our objective today is to use proportions to solve problems involving similar figures. Similar figures have the same shape, but not necessarily the same size. Similar figures have corresponding angles and corresponding sides. The symbol that kind of looks like a little squiggly snake means similar to. At the right, we have triangle ABC is similar to triangle XYZ. Similar figures have two properties. The corresponding angles have equal measures, meaning they're the same number of degrees. The length of corresponding sides are in proportion. So they're not equal necessarily, they're proportional. So like I said, the symbol with the little squiggly means similar to corresponding. So triangle ABC is similar to triangle XYZ. We want to state the similar sides. So what sides match up? So if you look at triangle ABC, and we find side AB. So it's the one that's kind of going, it's the vertical line, that side that's going straight up and down. Looking at triangle XYZ, which side would seem to match up to it? Well, the way I look at it, side AB seems to be connected to a right angle, and it seems to be the shorter of the two sides connected to the right angle. So if I look and find the right angle in triangle XYZ, the green one, what side seems to be shorter of the two connected to the right angle? And hopefully you're saying XY. So we would say that side AB is similar to side XY. So looking at side BC this time, which side do you think would match up with, from the green triangle, would match up with side BC? And hopefully you went with YZ. And then that basically just leaves us side AC, which, the only thing left is side XZ. So those are the similar sides. Now again, they're not equal to each other. I think you can tell by looking at the two triangles, the sides aren't equal. They're proportional. Okay, the length of the sides of similar triangles are always proportional to each other, so we can set up proportions. So first we need to find two similar sides with numbers. So let's go with side AB. What's going to match up with side AB? Hopefully you went with DE. So I'm going to put the little side, or the little side over the bigger side. Then we need to find the similar sides to the unknown side. So we've got side BC, that's X. What side on the other triangle matches up is similar to side BC? Okay, hopefully you went with EF. So we'll set that up as X over 10. We then set it equal to each other, and we cross multiply, meaning we're going to multiply the bottom left by the top right and the top left by the bottom right, which gives us 6x equal to 30. The coefficient is 6, so that means we need to divide by 6. When you have a number next to a variable, that means multiplication, which causes us to divide. So we divide both sides by 6, and we get x is equal to 30. And that's our answer. All right, I'd like to find side AN on here. So remember what we did last time. We're going to find two sides, or one side from each of the triangles that are similar to each other. So hopefully you went with AF and KS. So I went 104 over 48, so I went blue triangle over yellow triangle. Now I need to find the side similar to the unknown side. Well, the unknown side is AN, on the blue triangle. So looking at the blue triangle, let's go to green, I'm sorry. What side matches up with AN? Again, hopefully you went with 18. So we're going to go, we did blue over yellow. We need to do blue over yellow again. So we'll go x over 18. Since these are proportional, we'll set them equal to each other and cross multiply, giving us 48x is equal to 1,872. Since they're multiplying by 48, what do? We divide by 48 on both sides, keeping our equation balanced. And if you divide both sides by 48, you get 39. So side AN is equal to 39. Okay. Would you find side GS this time? So I want you to try to do as much as you can on your own. If you get stuck, unpause the video and see where to go next. But I want you to try to do as much as you can on your own. Okay. So find two similar sides. Might as well stick with what we know. We got 104 over 48. Worked for us last time. Should work for us again. Next, we need to find the similar side to the unknown side. Well, the unknown side is the x right here, so GS. So what matches up with x? That should be NF. I don't seem to have lost my F there. I hate when that happens. So we have 91 over x. We set those equal to each other. We cross multiply. We get some big numbers, so we have 104x is equal to 4,368. Again, what are they doing to the variable? They're multiplying by 104, so we do the opposite. The opposite of multiplying by 104 is dividing by 104. And we get x is equal to 42. Make sure you divide both sides by 104. Would you find n, please? So hopefully you found two similar sides with numbers. In this case, it would be the base of the triangles, 63 and 81. So I put the light blue, the turquoise, over the dark blue, and we got 63 over 81. But those are big numbers. How about we simplify that and put it as 7 over 9? Makes life a little easier. You should always try to simplify your fractions when you can. Alright, then we have our unknown side, is basically the side. So we'll have 28 over n. So we have 7 over 9 equals 28 over n. Notice if we had done 63 over 81, that would not have been fun. But doing this makes it a little bit more manageable. So our coefficient is 7, which means they're multiplying n by 7. Since they're multiplying by 7, we divide both sides by 7, and we get n is equal to 36. Would you find e, please? Doesn't matter that it's a polygon, a quadrilateral. It just matters that it's in proportion, which is what we're assuming all of these are. So, two similar sides. We'll go with that and that, the 30 and the 20, so 30 over 20. And we have our known side and our unknown side. So we'll say 21 over e. So we had big over little, big over little. Cross multiply. We'll get 30e is equal to 420. Our coefficient is 30. So since they're multiplying by 30, we divide by 30 on both sides. And we get e is equal to 14. And that's basically it. If you have any questions, you can post them on Edmodo or post them on at the end of the video on YouTube if that's how you're watching it, or you can wait and talk about it in class. Thank you very much.